So today, 1-to-1, creating linear equations in one variable. Now, you don't have to graph these. I actually want you to keep the linear part out of that. But anytime you have any kind of expression, and it just has x to that first power, right? That's a linear equation. It's in a certain form that when we get to start graphing lines, I'll break it down a little further. Don't worry about that for now. Today is very similar to what we did before. Remember, we had these. We had the sum of a number and 7 divided in half. Right, remember when I had this as part of the quiz? Who can tell me what I should write as far as my expression for this? There's no equal sign, but how did we interpret that? Let's see. The sum of a number and 7. What is the sum? Yeah. Okay. Adding. So we have the sum of a number and 7. So what should I put in my parentheses start? X plus 7. And actually 7 plus x would be correct in this case too. But we'll put it in descending order, always the variables first. Who knows what else we need to add to this expression? Yeah, Gabriel.
Divide in half.
Divide the whole thing in 2. It's this, the sum of this, divided in half. Okay. So if you were okay with kind of reasoning through this example here, then I think that today is going to click. If today doesn't click, I'm going to spend more time on it tomorrow. That's one reason as well why your homework is only 1 through 8 in the workbook. So very doable in one day. Yeah, if needed, we'll spend a little more on this tomorrow. Okay, so just looking at some vocab you need to know. Variable, the unknown problem. We're just going to use the unknown in the problem. We're going to use x. Okay, so the variable is x that we're going to use. And we are using only one variable, I think, for a while. So we're just going to use x. When you don't know something, you put it in as x. Now, unit rate. We see the word per. Per implies that it's going to be in some kind of ratio here. Now watch. It's whatever is measured divided by or over 1 unit. Okay? So 1 hour, 1 minute, 1 second. Do you, when you're driving, think instead of miles per 1 hour, would it be helpful to have miles per 3 miles per 3 hours? Would it be helpful to know how far you're going in 3 hours? Now, our unit for the base of our fraction here, the denominator is always 1 unit. There's, per 1 hour, per 1 minute, per 1 second. Okay? So we just got to keep that in mind. And when we go over these units up here, I think it'll make sense what I'm saying. But the main thing is, the unit rate is something measured over 1 unit. Okay, 1 hour, 1 minute, 1 second. So, for instance, 5 miles per 1 hour. We're used to seeing this, 5 miles per hour, right? That is just a unit ratio. It's just a unit rate, okay? So the 1 hour is important here. Because if the speed you were going was 5 miles per 2 hours, how easy is that? We don't use those kind of units, so that doesn't even make sense, really. You never really ask for more than the quantity of what's measured over 1 unit. In this case, the units are hours. Okay. Let's see if we can hit this with our examples up here. So, just looking at the board, kind of you can see that. The rate at which water fills up a swimming pool. What is the units? What units should be reported? So we have a swimming pool, right? We're going to have some fraction here. Now, often this bottom, the 1 unit, is talking about time. Okay. So do you think that we should measure how fast the pool is filling up by seconds, by days, by hours, by minutes? What do you think? The rate at which water fills up a swimming pool. Kaden, what's your reasoning? Yeah.
It should be like hours.
Hours?
Actually, I don't really know how long it takes to fill a swimming pool.
Yeah. Like say it's a big swimming pool.
Yeah.
It's definitely going to take a bunch of hours.
Yeah, but if you have like, yeah, I'd say hours because if it's a half day, it's like 1.5 days. It's
Right.
hard to. So.
Right. And what if it was a really tiny swimming pool? It's like one of the doughboys above the ground, right? You might actually be able to do that smaller one, you could do that in a couple hours, right? So I think you're right that we're not going to put days here. We're not going to put days. Who has another reasoning for maybe what else goes in here? So what did you say instead? Hours? Let's go hours. So we're seeing how much of what per 1 hour. Vanessa, what was your hand up? Gallons per minute. Okay. And there are, we made a reasoning for hours. I think it could be gallons, number of gallons per hour. It could also be, I like what you're saying, because gallons per minute, I think that might be what is like on a regular hose. That's how they measure it. But if you didn't know it and you made an argument, I actually agree. I agree with both of you. Okay, you're going to look at the scenario and decide what units you should use. And based on the scenario, it might be useful to do it in gallons per minute. It's a really small pool. It's a really big pool, gallons per hour. Okay, so with argument, both are fine reasoning. Okay, how about the next one? The cost of tiling a kitchen floor. The cost of tiling a kitchen floor. Let's see. The cost. So in this case, it's not time that is on the bottom of the fraction. What do you think, Gabriel?
Cost over square foot.
Yeah. So how about X number of dollars, right, per
Square foot.
square foot? Okay. So this could be, right, per 1 square foot. If you go and you buy, if you do the flooring, how they have like the laminate flooring, those actually turn out really good if you have a good flat floor. But the flooring they sell, they don't say, you get, square feet. We're looking for how much it costs. So we're looking for how much money per 1 unit, 1 square foot. So we can put this as X, we can put this as 1, and that is dollars per 1 square foot, dollars per square foot. The other way around doesn't make sense. The average speed of a falling object, okay? Average speed of a falling object. Where does someone think for that? Yeah, Gabe, you got another?
Weight over time.
Not quite weight. I like time. Per, are we going to talk about days when we're talking about a falling object? No, that's going to take forever. That's like a satellite. Seconds, I say seconds is good. Because even a minute, a free fall, you're pretty high up in the air. That's not how we usually do objects. Okay, what do you think? I like it. And in America, we're going to do feet per second. The rest of the world would be meters per second. So once you get to college, most things change to metric meters. Get ready for it. Okay, this is the last one. The rate at which a snail travels across a sidewalk. So talk to the neighbor for that one. That one's a little bit tricky, and that'll give me time to draw this.
Speed over.
Okay, 4 starbursts for you and your partner. Whoa, who has it? Isabel. Inches per minute. I like this because they're so slow. They're so slow. Who is your partner today? Oh, you guys are smart. Should have all spoke. You got it. Okay, distribute that to you. Brain mates there. Okay, I like this. Inches for a snail. Yeah, inches per, what'd you say? Minute. Because are they going to be able to do an inch per second? Nah, that's too fast. You got to see how the units will reason. Inches per hour. Someone could make an argument for that, but if we're crossing a sidewalk, I don't think it's going to take an hour to get across it. Okay, so minutes is good. It's perfect. Okay. Thumbs up, sideways, down for just unit rates. Feeling pretty good? Okay. Once you get the hang of it, you also get used. There aren't like infinite numbers of unit rates. Feet per second, inches per second. You know, you get used to the ones that are standard. That's what we'll go with. All right. All right. This next part is, I think, the trickier part of the lesson. So we have a process here, creating equations. This is our process. And we're going to do the process for, I think it was number 2. Yeah, number 2 in the workbook. So go ahead and look at the number 2 in the workbook, page 30 or something. And let's pull it up. Where is example 2? Here. Alright, number 2 right here is, I know it's a little low, but I don't want to give away the answers. Brianna has saved $600 to buy a new TV. If the TV she wants costs $1,800, she saves $20 a week. How many years will it take her to buy the TV? This would be tricky for anybody to just right away write out your equation. So we have this process. I want you to really depend on the process, because I worked it out with another Math 1 class, and actually it is really helpful. All right, so let's look. Read the problem statement. We just did that. Yeah? Okay. I see. Reread to make the list of known quantities. Okay, so who wants to, just looking through that, let's put the, make a list of known quantities. So we did number 1, check. Number 2, what are our known quantities? Give me one. Give me one. Okay.
How much she saved?
How much she saved? So she's already saved $600. Oh, 60. What's another thing? Yes, Magnolia. Okay, so the TV costs $1,800. Perfect. Okay, yes. How much she saves a week? Okay, she saves $20 per week. And our units there are dollars per week. We're going to see at the end that our units we're going to have to change them. No big deal. Read statement, ID the unknowns. So this is known. This is unknown. What is unknown? Gabriel.
How many weeks she'll have to save?
How many weeks? Perfect. How many weeks to save? Now, we don't know the number of weeks, so what variable do you think we should use? You can use whatever you want, but what should you use? You want to use X? If you chose to use W, would that be a big deal? No. Not a big deal, right? Variable could be any letter. We're going to call the number of weeks. How many weeks? We're going to call that X. This is my unknown. Okay. Now let's look. What's next? Create an equation from these unknowns and knowns. Okay. You want to help us with the equation?
Yeah.
What do you think?
20x plus 600 equals
20x, how much you're saving per week, plus how much you've already saved. When this equals 1,800, then we will have solved how many of these weeks we have. Because you know it's 600, $20 a week, so we need to see how many weeks do we need to multiply by 20, add it to 600 to get our total. That's perfect. That's perfect. And this is a linear equation. We could graph and solve this with a graphing calculator, but that's later. Don't worry about that. Anytime there's just next to the first power, it is a linear equation. We could graph it. My hand was up over here. Where'd the hand up? Yeah.
I was thinking we can also do the opposite way.
Okay, so 1,800 equals?
Yes, so I would do 1,800 subtracted by 600 and then divide that over 20.
So you're actually really what you're doing is solving this, because subtract 600 from both sides to start. So you're correct. You are making the equation kind of midway. And if you understand how that's the same equation, he's just midway through the problem, that's great. I want you to back it to this scenario, because that's going to help us when we get to the linear equation. It's good insight, though. If you don't see how that was halfway through, don't even worry about it. Let's solve this. Who can help me with that one? Yeah, Jack.
Subtract 600 from
Minus 600, minus 600. Perfect. If you need it really organized, you can use all these lines to kind of form it. Twice now. Okay. So 2x, that's gone, is equal to 1200. What's up? It's minus 0 days. It's non-zero day. Okay. All right, so the last person. Somebody new. Oh yeah. Not good. Evelyn. Begin. Good. It's 20 times x. Divide by 20. We're going to get rid of the 20. See ya. What is that?
60.
60. And 60 what?
Weeks.
Good. Let's look at the question again. Or actually, we solved for the variable. That was number 5. Number 6. Interpret the solution of the equation. Convert units if needed. What were we looking for in this problem? How many? Years. We have it in weeks. Is this a big deal? Could be, but I think we can do it. Converting units. I'm gonna show you some right now. I want you to make like a box like this, or just like a grid. This is what you'll do in chemistry as well. You have to convert units a lot, so let's get used to it. Whatever you're trying to convert, what you're trying to convert goes up here. That goes up there. Okay. And then what you're looking at, what we're going to do with this grid is we're going to multiply everything on the top together, then divide it by the bottom. So you're creating like a big kind of complicated fraction here, but it's not that complicated. How many weeks in 1 year? 52 weeks in 1 year. And then if you're like, well, where do I put that? Maybe I put it in the opposite direction. Would that, the opposite side of the fraction, would that make a difference? It will make a difference. So what you want to think about, what's helpful is, what you start with always goes here. I want to get rid of what units? I want my units in years, so what units do I need to get rid of? Weeks. Watch. Weeks up here. Weeks down there. We can cancel those units. Cancel. See how it's helpful? You organize a grid. I could be asking you to go from seconds to seconds to centuries, right? That's a big difference between those units. But with this, you'd be able to go, okay, 60 seconds is 1 minute. 60 minutes is 1 hour. 24 hours is 1 day. You'd be able to build it with each little segment. So let's see what we get. 60 divided by 52 is 1 point. I did this last time. I think it's 1.15. My guess last period was 1.16. Missed it. 1.15 what? Years. Done. This example is harder than the examples you have to do in the classroom, okay? But I wanted to give a little more challenge to it. Thumbs up, sideways, down for this. What do you think? Okay? I'll give the option. Does anybody want to do one problem from the classwork? Anybody need to see another example? Just want to give it a try? Do it on your own? Let's do it on your own. All right. Let's see. I have to change this. The 200th subscriber has subscribed. I'm at 200 today. It's big time. So they're going to get a Kit Kat, but it's Bridget Alexander. Bridget Alexander. And I don't know who that is. I don't think I have Bridget. So I hope it's someone in the school. Otherwise, we got to track them down. What should be the next number? Don't unsubscribe to subscribe. Whatever you do, that's the worst thing you could do. Don't unsubscribe to subscribe to try to beat the number. But what's the number I should go with? Not 200. We just got that. What's next?
900.
That's too many. I might not get that this year. 250? Yeah, that could do it. That could do it. That gives me a little time to promote it. Okay. All right, the 250th subscriber. I bought 2 Kit Kats, so you also get a Kit Kat. That's perfect. Let's see. How about just subscribe on 3? 1, 2, 3.
Subscribe!
Woo! That's good. All right, we go.